Welcome to lecture 5.4 on the properties of logarithms. Today we're going to learn how to convert from logarithms of products, powers, and quotients to expressions in terms of individual logarithms, and conversely. We're also going to learn how to simplify expressions of the type log base a of a2 raised to a power of x and base a raised to the power of log base a of x. A key thing to remember about all of these rules is that they are the rules of the logarithm of the rule. So for example, the product rule is for logarithms of products, okay? The product rule states that for any positive numbers m and n, and any logarithmic base a, the log base a of m times n equals log base a of m plus the log base a of n. And what this is basically saying is that the log of a product, sorry, let me get my pointer out here, the log of a product equals the sum of the logs of the factors. The log of a product equals the sum of the logs of the factors, whatever the product is, the factors of the product. Now the problem with these rules is that your brain, most of our brains work intuitively, and so they want to make up new rules. For example, they want to say the log of a product is equal to the product of the logs. This is false. The log of m times n is not equal to the log of m times the log of n. This is also not the product of logs. The second rule says the log of m times the log of n equals log of m plus. This is also false, okay? So it's the product rule is only for the logs of a product. When you have the logs of a product, then you can rewrite it as the sum of the logs of the factors. If you have the sum of two logs, you can write the sum as a single log, where the log is the product of each of the arguments of the logs that you're adding. So let's look at some examples. Express as a single log. Log base 2 of p cubed plus log base 2 of q. Here we have a sum, so we can write this as a single log by simply writing it as the product. Rewrite this using the product rule. The log of xy squared is simply equal to the sum of the logs of the factors. Here we have two factors. We have x and y squared. So we have the log of x plus the log of y squared. Here we have the log of x times the log of y. You might think this is the log of x plus log of y, or you might think this is the log of xy. Neither. This cannot be simplified. This is not the product rule. This is a product of logs, not a log of a product. This is a key distinction, and one of the things that trips up a lot of students, so be careful here. There is no rewrite or simplification for the product of logs, only for the log of a product. All of the rules are about, when it's the product rule, the log of a product rule. Okay, the log of a power rule, the log of a quotient rule, which we're going to look at. The second rule is the logarithm of powers. This is the power rule. For any positive number m, any logarithmic base a, and any real number p, the log of argument raised to a power equals that power times the log of the base. The log of any base raised to a power is equal to that power comes down in front as a multiplier, times the log of the base. The log of a power of m is the exponent times the log of the base. Here's the bad thinking. Notice in this example we have the log is raised to a power. Not the log of a power, but the log is raised to a power. This is false. You cannot bring the exponent down in front if you have the entire log raised to a power. Sometimes these are actually written with the square right after the word log, so it would be log squared m, and that means the same thing. So be careful again. Watch your intuition. Let's do some examples. For a, log base a of 11 to the negative third power, that negative 3 comes down in front and becomes a multiplier. For b, the log of the fourth root of 7. Now remember that the fourth root of 7 can be written as 7 to the power of 1/4. Radicals are can be written as exponents, with the root of the radical being the denominator and any power or exponent inside being the numerator. So we get the log base a of 7 to the 1/4, and again that 1/4 comes down in front as a multiplier. For c, the natural log of x to the 6. Remember that the natural log is simply log base e. So again, we have here, I'm sorry, that doesn't even matter. I don't know why I said that. Again, we have the natural log of x to the 6th power. The exponent comes down in front of 6 times the natural log of x. For d, 4 log x, we have a multiplier in front. We can take that multiplier and turn it into the exponent on the argument. So 4 times the log of x is the same thing as the log of x to the 4th power. For e, this cannot be simplified. Again, we're applying the power to the entire log, not to the argument of the log. So this cannot be simplified. It's not part of the power rule. The quotient rule. For any positive numbers m and n, and any logarithmic base, the log base a of m divided by n equals the log of m minus the log of n. The log of a quotient is the log of the numerator minus the log of the denominator. Again, this is the log of a quotient, not the quotient of logs. So here's our bad thinking. Our brain wants to make things neat and tidy and symmetrical. The log of a quotient is not equal, this is false, to the log of the numerator divided by the log of the denominator. This is false. Okay, and also if we have a quotient, the log of m over the log of n, this does not equal the log of m minus the log of n. The quotient rule is for the logs of quotients, the logs of fractions, if you will, not the fraction of logs. Be careful. These rules are easy to mess up, so it's important that you memorize them and know them. So let's look at some more examples. The log base t of 8 over w. This gives us the log of the numerator 8 minus the log of the denominator w. The log of x squared over 3. This gives us the log of x squared, the numerator, minus the log of the denominator 3. The log of x squared over the log of 3. This cannot be rewritten or simplified because this is not the log of a quotient. This is the quotient of logs. And the last one, log 6 minus log 2. This gives us the log of 6 over 2. That is a fraction that can be simplified, and we should do that. So this simplifies to simply the log of 3. So now let's try to put all of those things together. Now, these can be complicated, but once you've worked them a little bit, they actually can be done pretty quickly, given a basic rule that anything in the numerator is positive and anything in the denominator is a negative log. But let's go through the steps for all these, and then I'll kind of walk through that shortcut in my mind. All right, so we have the first one, a. So the first thing we can do is separate the numerator and denominator. So we get the log of the numerator minus the log of the denominator. Now the numerator is a product, so now we can rewrite this first log using the product rule. And remember, the log of a product is equal to the sum of the logs of the factors. So we can rewrite this first log as log of x squared plus the log of y to the 5th. We now have exponents on each of the arguments of the log, so we can bring all of these exponents down in front. And so we get 2 log x plus 5 log y minus 4 log z. All right. Now here's the shortcut I'm going to remind you of. Okay, so we have the log of this pretty much complicated quotient or fraction. So everything in the numerator is positive. So I have x squared. So just this first term, I get 2 log x plus 5 log y in the numerator minus 4 log z. Everything in the numerator is positive. Log x squared plus log y to the fifth. Everything in the denominator is negative minus log z to the fourth. But knowing the power rule, I can also take that apart as well. So 2 log x plus 5 log y minus 4 log z. So once you get those three and how they work together, numerators are positive, denominators are negative, I can almost move directly from the original expression to my final answer. Let's look at B. Now here I want to rewrite this first so that it's exponential in nature. This one is more complicated because I have exponents on the entire argument, so I can pull this 1/3 down at first. And so I get 1/3 times the log of a squared b over c to the fifth. Now I can apply that simple rule, which is 1/3 times 2 times log a plus 1/3 times log b minus 5 times 1/3 log c. But let's go through the steps. So here we can do the numerator minus the denominator. So here I get 1/3. Now make sure you put parentheses around it because this is 1/3 times everything that's going on now. So I get the log of the numerator, a squared b, minus the log of the denominator. That's the quotient rule. Then I can separate the first log into factors. This is the log of a plus the log of b. But a has a 2 as a power, so I can bring that in front. 2 log a plus log b minus 5 log c. So here I've done the product rule and the power rule twice. Now I need to distribute the 1/3, and so I get 2/3 plus 1/3. Oh, I didn't even notice that. All right, what happened here? I missed a step here that I didn't explain. Remember that when you take the log of the base, this is equal to 1. So this just drops right out. I didn't notice that it's the log of base a of a. Remember, when you take the log of the base, this equals 1. So we just get 2 there. Now we distribute the 1/3, and we get 2/3 plus 1/3 log b minus 5/3 log c. Let's look at another one. Let's look at our final answer here. This is the log of b times a y to the fifth over m cubed n to the fourth. Okay? So I can go ahead and move this b into the numerator, which might help me a lot more. Oh, that was really confusing. My bad. This b here should be smaller. This is the base. This is log base b of a y to the fifth over m cubed y to the fourth. So we have the log of the numerator minus the log of the denominator. Now we have two products, a product in the first log and a product in the second. So I can separate those into the log of a times the log of y to the fifth minus, and again, notice I'm using parentheses. It's a good idea to use parentheses in these product rules and in the quotient rules. Minus the log of m cubed plus the log of n to the fourth. Now I can bring those powers down in front and distribute the negative. So I get log of a plus log, I guess they just distributed the negative first. My bad, I'm not following my own notes, sorry. So here if we just distribute the negative so we can get rid of the parentheses, that might make it a little bit easier and clearer first. Log of a plus log of y to the fifth minus log of m cubed minus a positive is minus log of n to the fourth. Now, sorry, we bring those exponents down in front. 5 log a, 3 log m, 4 log n. Okay. Now, if you remember, I talked about going directly, excuse me, sorry, from the original problem to the answer. But remember, everything in the numerator is positive. So I have the log of a plus 5 log of y. minus 3 log of m minus 4 log of n. So again, if I remember that everything in the numerator is positive, everything in the denominator is negative, I can pretty much go directly to this final answer. In B, it was a little more complicated because we also had another power on the outside of the argument, and we had to bring that down first. So be careful with these. They are confusing. Take your time and be careful that you don't make up any rules. So let's try to go backwards. This is not quite as easy, but it could be. Remember that anything positive is in the numerator, so I'm going to have x to the 5th in the numerator. Anything negative is in the denominator. I'm going to have y in the denominator. And here I'm going to have, this is going to be in the denominator. I'm sorry, this is going to be in the numerator. It's positive. My bad. I'm going to have a z in the numerator, but remember the 1/4 in front, a multiplier by the power rule becomes the exponent, z to the 1/4. But let's go through it more, a little bit more slowly. So here's the original problem. We can pull the exponents back up. Any multiplier in front becomes an exponent on the argument, so we have x to the 5th. There is no exponent here, so I'm not worried about that. And then we have z to the 1/4. Okay. Remember again that when we're subtracting things, it becomes the denominator. So I have x to the 5th over y plus the log of z to the 1/4. Well, remember again, when I'm adding things, this becomes part of a product. So I'm going to multiply this argument, x to the 5th over y, by z to the 1/4, which puts it in the numerator. And so I have, again, if I look at the original, the log of, this is positive, x to the 5th in the numerator. This is positive, z to the 1/4 in the numerator. This is negative, so y in the denominator. X to the 5th, moving the exponent up. Z to the 1/4, moving the exponent up. And y in the denominator. And of course, z to the 1/4 is the 4th root of z to clean that up even more. Now this is a little tricky game that a lot of students hate, but I think it's a good way to practice kind of rewriting things, all right? So imagine you have a calculator, and your calculator only has 2 buttons. It can tell you what the log of 2 is, and it can tell you what the log of 3 is, nothing else. So what we have to do is try to rewrite each of these arguments in terms of 2 and 3, okay? In terms of the log of 2 and 3. Well, 6, for example, in A, 6 is equal to 2 times 3. So I can rewrite the log of 6 as the log of 2 times 3. Well, that's the log of 2. Using the product rule, that's the log of 2 plus the log of 3. Well, now all I have to do is substitute in these values from my calculator, add them together, and I get the answer, which is 0.778. Okay? B is pretty simple, because it's already written in terms of 2 and 3. So I get the log of 2 minus the log of 3. I substitute in the values, and I get approximately negative 0.176. Let's look at C now. C is the log of 81. Now how can I rewrite 81 in terms of 2's and 3's? Well, 81 is actually 3 to the power of 4. So here I can rewrite this using the power rule by bringing the 4 down in front, and now I can substitute in the value of the log of 3 and then just simply do the math and get 1.908. For D, I have the log of 1/4. Well, this is the log of 1 divided by, this is the log of 1 minus the log of 4. Well, 4 is 2 squared. So again, I can rewrite that as 0. Now, why is this? Remember, the log of 1 is always 0, so we've gone ahead and plugged in that value. Here, we can pull the 2 in front, and we get 2 times the log minus 2 times the log of 2. And then we can plug in the value, and we get our answer of negative 0.602. Okay. For E, we have 5. Now, be careful. Here's where your intuition wants to do crazy stuff. You want to do this as the log of 2 plus 3. There is no rule for the log of a sum. There is no sum rule, okay? So there's no way that we can do this problem given the information we have, okay? We cannot rewrite this as the log of 2 plus 3, or we could in parentheses, but we can't simplify it beyond that. It's not the log of 2 and the log of 3, so we cannot do anything with e, okay? Here we have the log of 2 divided by the log of 3. We can solve this problem by simply plugging in the answers, but be careful, this is not equal to the log of 3 minus 2. Be very careful. We just have to plug in the answers. Remember, the quotient rule is for the log of a quotient, not the quotient of logs. So here we just plug in the values and we get our answer. All right. We already know this rule, and that is whenever we, when we take the log of the base raised to a power, this equals the power. The logarithm base a of a to a power is the power. And this goes with the idea that the logs and exponents are inverse functions, okay, inverse operations. Just like if I add 2 and subtract 2, I end up back in the same place. So if I take the log of base a raised to a power, I'm just going to get back to that power. The log cancels out the exponential. Okay, so these are pretty straightforward. For a, we have log base a of a to the 8th, so the exponent is the answer. In b, we have the natural log of e to the negative t. Well, remember that the natural logs are a base e. So here we're taking the log of the base raised to the negative t, so the answer is just the exponent. And log, when there's not a base written, is a log base 10. And so here we have a common log, they cancel out, and we just have the exponent. This also works in reverse. If you have the base a raised to a power, and the power is the log of that same base a, then again, these cancel out, and we just have the argument of the log. The number a raised to the power log base ax is simply x. All right. So here we can see the bases are the same, so our answer for a is simply going to be the argument of the log, which is k. In b, we have, again, remember, natural logs are log base e, so they cancel out, and we just get the answer of 5. And in answer c, when we don't have a number at the base of the word log or right after it in subscript, this is a common log base 10. So we can see that they cancel out, and we just get 7t. These are pretty straightforward. You've got to practice them. I mean, it's all new, so it may not seem straightforward to you, but that just comes with the practice. All right, have a good lesson. Reach out if you need any.